Hello, this is Mr. Marshall for Truganina College Year 9 Maths Algebra Misconceptions. We are looking at algebraic misconceptions that students make, and we will be reading through, and you will need to copy the learning intentions and success criteria into your exercise book. As we go through the slides, you will need to pause and take notes and then answer the questions that are listed at the end of the slides with the exercises that are listed in your packs for this week. Today we are creating algebraic rules. This is something that we've done in previous years, and we are just revisiting it to make it fresh in our minds and also to make sure that we know how to do this. We're learning to create simple algebraic rules from a sequence of numbers, and my success criteria is I am successful when I can find the initial value, which is the zero value, and create a rule from a table of numbers. Now, what is a rule? A rule is an equation that describes a relationship between the x coordinates, or the inputs, and the y coordinates, the outputs, on a table or graph. Now, sometimes we might not be using x and y, we might be using other coordinates, but it's about that input versus that output. So we have this rule here. Y equals something times x plus something. This is our general rule. And this coefficient, this first something, is the number that y increases by for every time x increases by 1. You may have noticed this back in lesson 2 of this topic when we were looking at tables and creating tables from the rules. You might have noticed that pattern. And if there is a decrease in y, this will be a negative number. This last value here is the constant, and that is the initial condition when x is 0. So here's a couple of examples, and we'll go through how we get from this table here to these expressions. And if the value of y when x is 0 is not given in the table, these tables both have x's as zeros, we need to substitute in another pair of coordinates to find that value. And after completing the rule, we can always test to see if we're correct by grabbing one of these pairs of numbers and substituting it in to prove that it's correct. So here's our first example. Find the rule from this table. So we've got a nice table. X is going up by 1. We have a 0 for x, and we have y here. So this is my thinking, this is what I write and draw. So I look at this table and I can see it's counting by 3s. And in your workings you would show this to me, showing that it's counting by 3s each step. So we know that the coefficient of x is going to be 3 because it's going up by 3s. So that gives us that 3 there. And our initial condition when x is 0, here's our minus 2, so that's our constant, minus 2. Now, let's substitute in a value. So let's pick this last value here, 2, 4. So when x is 2, y is 4. Let's put this into this equation. So let's just put in the x value, 3 times 2 minus 2 is 3 times 6, or 6 times minus 2, and which is 4, and that gives us our answer. So we know that this equation for that value works. If we want to double check it, we might want to pick a different value to see if that also works. Here's another example. Now this one's a little bit harder. We don't have that x is 0 value. So we'll go through. We can see that it's increasing by, well, decreasing this time by 2. So it's increasing by negative 2 each time we move along. So our coefficient is negative 2. So we've got this equation, y equals negative 2x plus some number. We don't know what that is. So to find a constant, we're going to pick one of these values. Let's pick 3 and negative 5, and we're going to substitute it in. So we've put in 3 where the x was, the minus 5 where the y is. And then we solve that, and we get negative 5 equals negative 6 plus something. And when we rearrange that, we get that something equals 1. So we can rewrite the rule as y equals negative 2x plus 1. And again, we can substitute in. I just picked this value in the middle, 5 and negative 9. And I tested it. Negative 2 times 5 plus 1, negative 10 plus 1 is negative 9. So we know it's correct. So for our practice today, practice level students will be doing these questions here. Consolidating level students will be doing these questions, and the master level students will be doing these questions. And for reflection, I want you to create a matchstick problem like number from question 8. Make your own pattern and then create that table and then work out the rule for that pattern and see if it works for your pattern.